Welcome back to my series on implicit differentiation. I will be doing, as the title says, implicit differentiation basic. I'll be doing basic examples, just using x and y's only. I won't be using any e to the power of x or trigonometric functions of sorts. So it's just going to be basic stuff, just to get you used to the techniques. Now keep in mind, I'm not going to be teaching you derivatives. I have a whole series on that. This is just applying those techniques. So if you don't understand the techniques, you probably don't understand derivatives enough to do this. Okay. So anyway, let's start with example 1. We have x, y plus 2x plus 3x squared equals 4. Now this may look complex. It's not complex. We're going to find the derivative of each one. There's only one y value, which means there'll only be one derivative of y. So it's going to be pretty easy. Don't worry. So first things first, find the derivative of each side. Okay. Now we've done that. We've labeled that we're finding the derivative. Now we're going to put the derivative on each one of these separately. Now usually when you do derivatives, you do this unknowingly. Like if I was going to derive this, if it didn't have a y and I was going to derive this how I would normally, I wouldn't even do this step. I would just look at it and derive it. But because we have a y, because it's implicit differentiation, because I'm teaching you how to do it, we take these steps to make sure we don't mess up anything. And the derivative of 4 is just 0, because the derivative of a constant is 0. Make this look a bit more like a y. Okay, so we have the product rule over here. We'll call this one u and this one v. Only because they're not two separate planes. Like we haven't got a y plane and an x plane. It's not like partial derivatives. We've just got x and y, which is a function of x. So y is a value of x. Okay? It's not x, it's a value of x. So what we're going to do here? Well, we're going to find the derivative, which is u dash v plus u v dash. That's the product rule when you have a function times another function. Okay? Plus, what's this? The derivative of 2x. Well, if you watched my previous video, you would know that we separate this. I'll do it for this one as well. We separate it with brackets because technically you use the chain rule to solve something even as simple as this. You just don't, because it's much quicker and it's easier to understand without it. But for this case and this purpose, we will use the chain rule. So the derivative of 2x, well, it's just 2 multiplied by the derivative of the inside. Like you get rid of the x, but what's the derivative of the inside, which would be the x? It would be the derivative of x with respect to x. Okay? Now, this equals 1. That's why if you were to derive 2x, you would get 2, because 2 times 1 is 2. It's just, we use this for this reason over here that I'll explain later. Okay, anyway, chain rule for this one. Bring the 2 down, multiply it onto the 3, you get 6. X, because you take 1 off the power, the x stays, but then you multiply by the derivative of the inside. You multiply by the derivative of x with respect to x. And all of that equals 0. Okay, back to here. U is x, so u dash, the derivative of x with respect to x, multiplied by v, which is y, plus u, which is x, multiplied by the derivative of v. If v is y, then the derivative would be the derivative of y with respect to x. That's the derivative. This is what we're looking to isolate. Okay? And here, well, 2 times 1 is 2, plus 6x times 1 is just 6x equals 0. These steps aren't usually necessary. I'm only doing it to show you the thought process. Okay? You don't just say the derivative of x with respect to x is 1 when you're beginning this. You do it. You take your time and you do it methodically. You be very precise in your workings, because when you're first starting this, or even if you're not first starting this, it's very easy to make a mistake when you don't put in all the details. Okay, so the derivative of x, the derivative of x with respect to x is 1 times y. We just have y plus x multiplied by the derivative of x, y with respect to x, so the derivative, that just stays there, plus 2 plus 6x equals 0. Okay, so what I'm going to do is rearrange this. I'm basically just going to bring this onto the other side, the x multiplied by dy dx. So we'll have 6x plus y plus 2 equals negative x multiplied by dy dx. Okay, all I did was just rearrange these to make them look neater, and I subtracted x multiplied by dy dx from either side. Okay, now I'm going to isolate this. This is multiplied onto negative x, so I need to divide both sides by negative x, which will cancel out this one, just leave dy dx on its own, and this will be my answer. So dy with respect to x, or the derivative, equals 6x plus y plus 2 all over negative x. And that is your answer using implicit differentiation. Okay, hope that wasn't too much, but I will be doing another example. So we have example 2. 2 on x minus 1 on y equals 4. Just to clarify, these aren't supposed to be easy. I'm just doing one video on basic, one video on trigonometric, one video on so and so, because you should know the techniques. This is just learning a different way of applying those techniques. The techniques of derivatives that I have plenty of videos on. Anyway, so we have 2x. This also equals 2x to the power of negative 1 minus y to the power of negative 1 equals 4. Why? Because 1 over y, that has a positive 1 power. If you bring it to the top, it has a negative positive power. It has a negative power when you bring it to the top. Same as this. This has a power of 1. If you bring it to the top, it has a negative power. Okay, so what we're going to do is find the derivative of either side. Can't fit that in. Yep. Now the derivative of, we're going to split this up. We're going to have 2x power of 1 plus the derivative of negative y to the power of negative 1 equals the derivative of 4. Okay, so we use the chain rule, just like before. We put these in brackets if you need to. Okay, so the derivative of the outside, bring the negative 1 down, we'll have negative 2x, take 1 off the power, be negative to the power of negative 2, and then multiply by the derivative of the inside. Derivative of x with respect to x is 1, but we still write it. Now the derivative of negative y to the power of negative 1. Chain rule, you do the outside, you bring the power down, multiply it on negative 1 multiplied by a negative is just positive 1 multiplied by y. Well, we take 1 off the power, so it would be to the power of negative 2. And then we multiply by the derivative of the inside. So the derivative of y with respect to dx is dy dx. And that equals the derivative of 4 is 0. Okay. So this, we're going to bring this onto the other side. Just keep in mind, we don't have to write this because that equals 1. So 1 times whatever, we're just going to cancel this out. So we're going to bring this over the other side and make it a positive. So we'll have y to the power of negative 2 multiplied by dy dx equals 2x to the power of negative 2. Keep in mind, I got rid of this 1 as well, because 1 times that is that. Okay? Now, the next step, we're going to divide both sides by y to the power of negative 2. And what that'll do is cancel out these. And what we're left with is, I'm going to need another piece of paper. What we're left with is we've got the derivative on its own equals 2x to the power of negative 2 on y to the power of negative 2. And just like before up here, you should know this, but just like how we have to the power of negative 1, just like we have, if it's a positive on the bottom and we bring it to the top, it's a negative. If it's a negative on the top, we bring it to the bottom. And if it's a negative on the bottom, we bring it to the top. That's what you do to make them positive. Okay? So we're going to bring this y to the top. So we'll have 2y to the positive 2 over. We're going to bring this x to the negative 2 down to the bottom to make it a positive. So we're going to have x to the power of 2. And that is your derivative. And that is what you use to find the slope on whatever this graph looks like at 2 points. Okay? Now, thanks for watching my video on implicit differentiation basic. I hope you had a good day, and I hope you learnt something.